Hello everyone. So if you remember this deer character that I worked on a while ago, so I wanted to create an NPC deer character system like a herd of deers um, which roam around the world freely and maybe run away from the player when he sees some player character, or maybe even a wolf character that I worked on before. So yeah, but when I try to implement that, I figured out so as you can see here, this whole uh, deer animation, deer locomotion is based on the Rootmotion enabled character animations. So this character movement is completely driven by Rootmotion of the animations, and as a result of that, we can't use the usual AI MoveTo function to drive the character through an AI class, an AI controller. So the reason is this. Let me explain again. In this deer character, let me open it. So here, this is here we have the movement inputs like this. Actually, this is what I copied from the third person character template, but this is not really working. So even if I delete this, character will move just fine. See, it is still moving, the inputs are still working. The reason is this. Let me open the character animation blueprint, and here I have enabled root motion mode to root motion from everything, and then this basic animation blend space, I'm using this one. All these animations are root motion enabled animations, so that's why the character turning and walking and everything smoothly match with the actual moment. So right, so now I set this side speed and forward speed like this. Oh, sorry. Using this get desired movement. So what this function does is, let me show that too. So it returns the what is the direction character is trying to move to. It returns that direction like this. Along the forward vector, it multiplied by the move forward input axis, and then also the right vector multiplied by the move right axis value, and return it. So here, so we play an animation which is suitable to move the character in this direction. So when we play the animation, because of the root motion, character actually moves. So it's but in other cases, for example in this third person character, if I show you the animation, that's not the way it works. So here what we do is we play an animation to match with the movement of the character, but in here we play an animation, and from the animation we get the actual movement through root motion system. So it may be kind of confusing, but here animation is doing the work, but in here the animation is just playing to show that character is moving, but even if the animation is not there, character will move. But in the deer, if the animation is not there, character will not move. Right. So but in order to control through usual AI movement, AI move to nodes, the character should work in the way this third person character works. So to show you that, let me place a mannequin character like this, and also we need a navigation mesh, nav mesh, bounce volume, place it like this, 20, 10, 50, 50. Okay, why this area is not navigable? I'm not sure. Okay, let's see. Right, now if I go to the third person character, what are these? I don't need them. And in the begin play, do we have begin play? No. Okay, in the begin play event, if I add an AI MoveTo node from get actor location, and let's add some value to this, let's say move 1000 units along the y direction. Right, let's play the game now. So I'll change the game mode to none, so I can just spectate. It didn't work. Here we need to give a reference to the pawn, so I'll give self, that means this character. And if I play the game now, you can see the NPC character is moving forward. So now if I do the same, and this is ch stack stack character, let me copy the same thing into this stack. Let me delete this, I don't need it. So let's see, so stack is also moving, but the issue is it's not showing any animation. So yeah, the reason is what I explained before. Here the animations are not playing to simulate the actual movement of the character. The animation AI system I have implemented, what it does is, based on the animation, the character movement happens. But so how to apply, so how do we work with this animation system for NPC characters, for NPC stack characters? So that's the problem I want to solve here. Right, so let's create a custom AI MoveTo function to work with the existing animation system we have. So I'll delete this, and let's create a custom event. Let's call it stack NPC MoveTo. So let's add an input in the type of vector called destination. Right, now using this destination we can call find path to location synchronously. So this is not the start. Path end is this destination. Path start is get actor location. Right, now from this we can get path points. So this returns the points in the path returned by the navigation system. To demonstrate these points, let's just do something like this. For each this and line trace by channel, start is this, end is the same thing, plus 100. So let's just do and I'll draw it, make it persistent so I can see these lines. So in the begin play, if I call npc MoveTo, same as before, get actor location and add thousand units salon y. Let's see. Now you can see here is 1 point and here we have another point. So those are the 2 points returned by the navigation system. Right, now we don't need this. It's just to show the points of the path. So how do we move the character? Right, let's add another variable. Let's call it AI moving, and then get points, get path points, and let's promote this to a variable. I call it path points. Now path points, that sounds nice. Right, and then I'll set AI moving to true. Now in this get desired movement function, so this part will only work for the player controlled characters. So let's have a branch here using AI moving. I'll break it and add it here. This is for player controlled movement, and here if it is AI moved by the AI, then we should get the now path point, and we need another variable to hold the index. So now path index, it should be an integer, right? And here I'll set now path index to 0. Maybe I should do that before setting AI move to true. Right. Also I'll add another parameter here called acceptance radius. default, I'll make it 50. I'll set that to. So if the character goes to this point, we will consider it as reached that point. Okay, now here get now path index and get no count or length, get the length of this now path points, or maybe not the length, let's get last index. And if this now path index is smaller or equal to the last index, so what I'm trying to do here is I don't need to try to get something, try to retrieve some value from this array which is not there. So if the number of points are 3, we shouldn't try to get the fourth number. So that's why I'm doing this check first. The branch, if this is true, that means we have a valid index. Get a ref, get the next point in this path points, and then get actor location. And let's first check the distance. Distance from between this actor and this target point. If this is less than the acceptance radius, let's have another branch here. If this is true, then we will simply increment the now path index, and yeah, that's it. Otherwise, add a return node and get direction from this point to from the actor to this target point, and I'll return it as the desired movement. Well, let's see what happens. Character is not moving. Let's see if this is called. Oh yeah. What's the value here? Can we see that? Oh yeah, first one is 600, 300, 3670. What's that? Is that the same as? Yeah, it's same as the initial location. So instead of setting this now path index to 0, I'll set it to 1. Alright, now it is moving. And also it has the proper animations as well. So what if we add some blocking object here, like this? See, now character avoids that object. and it fails. Let's show navigation. Why is that? What if I place this character here? It can go, but the rear character can't go. To see the point it's trying to reach, let's add another line trace here. And let's keep the line for 1. Okay, now the character does reach this point, and why it doesn't move after that? One more thing here, if we reach the end of the point, we should set AI moving to false, but that's not the solution for the current problem I have. That's something else. So here let's print this difference I get here. Get is reducing. Right. The reason is, I think this 80 is the half height. Yeah, it's the half height of the character. So I think for this acceptance radius I should not use something less than that. So let's say 100. Yeah, now it is working. Cool. See, it can walk around it. And it should stop this when it reach here, but it's not. Why? 133 difference is there. How does that happen? Let me toggle debug camera. Okay, so there is a difference here. Alright, so to calculate this acceptance radius, I'll only consider x and y values, not the z value. So how to do that? Oh, well, we can break this one and break this one. Oh, actually there is an easier way. All we need is a distance, so get this one and then get vector length xy. and use that here and here. That should do the trick. Let's see. Okay, now it is stopped. Alright, so yeah, now we know how to drive our character NPC AI driven characters with Rootmotion enabled Locomotion blend space. So yeah, I'll stop it here. And yeah, this is basically what I wanted to solve before implementing the AI behaviors of this deer herd. So just to sum up what we have done here, let's add few more characters. And then instead of asking them to go like this, let's get a random reachable point in 3000 radius and ask it to move, and at a delay of, let's say, 10 seconds or maybe 8 seconds, and call it again, so they will randomly move around. And let's see how it looks. Cool. Yeah, now we have actually not a well organized but some herd of deers. What else we can do? Well, let's make them behave more like a herd in the next episode. For now, I'll stop it here. And thanks for watching. So if you would like to support my work, you can get the membership of the Patreon club. Link would be in the description below. And also the project files of this project will be available for the download through the Patreon page. And see you in another episode. Goodbye. Almost forgot. This episode is sponsored by these generous patrons. Thank you very much for the support you guys are giving me.